Alright, alright guys, we are now at question number 2. Okay. So question number 2, first we have this circuit here. Okay, so let's look at this circuit now. So we have 12 volt DC here on the right hand side, and then on the top here we have 4 volt. Okay, and the polarity is a bit reverse here, positive here, right? Okay, then we have another, this is the current source. How do I know? You look at this arrow. Arrow means is the current. So positive, negative means the voltage. So this current source, and this current source, the value is half of this IB. So whatever current flowing through this 1 ohm, the current here is half only, 0.5 IB. IB is here. Okay. So this means this current is half of this IB, and then if you measure across this current source, you can get 1 voltage also. They call it the Vx here, and you are required to find this Vx, the value of Vx, how many volt across this current source. Okay, so the let's look at this one. All right. So what you need to do here is you need to first do the KCL. Okay, you need to do the KCL here. Kirchhoff current's law. Okay, at this node here. So we have IB, with IB going in, we have this half of IB going out. Okay, half of IB, you see the arrow here is going this way, arrow going this way, right? So going this way. So it's going this way, going out, 1 in, 1 out, and this one we assume is going out. Okay, we assume because based on this one analysis, if this is a current and this is a positive, and if the current start from here, follow the IB, and then this current must be falling down. Okay, this is the initial assumption. So we get the equation using the KCL. So the equation is IB equal to IX plus 0.5 IB. Okay, right here. So IX is unknown. So if you solve for this one, we have IB, 2 IB here. If you solve for IX is actually equal to half for IB. So we are quite sure that this IX is equal to 0.5 IB. Same with this one also. Okay, same with this. All right, so the second step you need to do is do the KCL around this loop here. Do the KVL around this loop. So we start from IB here. IB, this is Ohm's law, right? Ohm's law, voltage multiplied by the resistor is equal to voltage, right? So we do the voltage here. Okay, so we get one current, the other one must be resistor. Okay, and then the other one is IX, current, and then resistor, right? And then minus something equal to 0. So everything, sum of all the voltage here, sum of all the voltages around this loop must be equal to 0. Okay, here. And then by doing this, since in this all equation here, eventually if you replace the IX, with 0.5 IB, in this equation you see all the IB, and then you can get IB equal to something, right? And then by doing that, you also know that Vx is equal to 0.5 IB here, and then you can find the Vx. Okay, for the part 2, you need to calculate the power, whether it's absorbed or supplied by this forward, whether this forward voltage source is supplying or absorbing the power. So we need to find out. So the equation for the power is also simple. It's a V times I. So the I, you should know what's I, right? I cannot tell you. The I is very obvious. What is the current flowing through this? So you just multiply by the voltage, multiply by the current flowing through the voltage source. You can get the power. And then from there, you can decide whether it's absorbing or dissipating. So if you get the positive, that means it's absorbing. Absorbing means it's dissipating, it's using. If you get a negative, that means it's supplying. Right? Negative means supply the power. So you need to look at the polarity here to decide whether it's absorbing or supplying. So for the part B, you are given this circuit here. Actually, you can use the one we learned, convert from the, see here's a star. You can see here's a star. Here's a star. This one's a star. You can use the formula we learned, convert from the star to the delta. Okay, you can do this technique. The other technique you can use is, you look at this one, this node is actually connecting to this node, right? That means this 6 ohm is this 6k ohm is actually, you can just ignore this line, you can join this node with this node, then it become 12k and 6k. They are sharing the same node here, only 2 nodes. That means this is a parallel, right? This is a parallel. Then that means you can calculate, you can reduce this one into one component. After you reduce one component, then this component and this component together, they can reduce some more. Okay, and eventually you will reach only one resistor. So this is quite simple. You just need a few steps. Okay, starting from this step here, solving the parallel resistor. Then what you get is this 2k with this resistor. You solve just now. Then this is in series, right? So you solve the total resistor here, and then you step by step you just applying the parallel and the series resistor calculation the equation. Okay, you can eventually reach one resistor value. We call the equivalent resistor value. In this case, the RAB. That means if you measure this point, or what is all resistor here. Okay. All right, for the part C, it's quite simple actually. You don't need to worry about this. So I give you one most important equation here. So for the loop 1, if you assume this is a loop 1, okay, I1 is a loop 1, you're using the KVL, sum of all the voltages around the loop. Start with here, minus 80 plus 5 ohm multiplied by loop 1 current, and then plus this one, okay, plus this 10k. But this 10k is between current 1 and current 2. So that this current is going down, and then we assume the current is going down, right? By putting the positive here, negative here, we assume the current going down. So I1 is a positive, I2 is a reverse, right? I2 is going up, right? If you follow this loop here, I2 is going up, right? Don't worry about this, okay? When I2 is going up, then the I2 is minus I2. Okay, then you do the other equation here at this I2. Okay, you do another equation here. It's quite obvious here actually, and then you can eventually solve for the I1 and I2. Okay, so this is pretty simple for part ABC. Okay, it's a very good practice for you to do yourself. Okay, that's it for question 2.